Let there be light.
Hey Breakerspace, Dev here. Welcome to our new channel and to the first video. Setting up a studio is not that easy. We need a lot of equipments like lights, camera, audio, etc. etc. But being a workshop DIY makerspace, we thought why not give it a spin and start by making our own equipments, which is not gonna be as easy, but it's gonna be fun. The first order of business would be to start by creating the lights. Let's get started.
Well, it's not that I don't have lights. I have made some, bought some, or even I have Frankenstein some from salvaged parts, but they don't qualify as being studio lights. So I'll have to make my own lights. Let's start with the frames. These are a couple of old salvaged laptop screen frames. Let's start with this one because this is the most hardest one I imagine. If we can prototype on this one, the other ones should be easier. I already have a stockpile of LED strips, but I'm going with this Proteum Daylight White. It has 240 LED per meter, which is fairly bright for our purpose. The thing about LED strips is that they're not very power efficient. They use series resistors as their constant current source, which means almost half the energy gets dropped as heat and only the other half gets transmitted as lights. So with that in mind, the power budget for this light is going to be somewhere around 20 watts. I'm going to cut the LED strips into pieces and it will be around 1.5 meter altogether in 4 strips. Now, the reason we started with this particular frame is because its backplane is super uneven and it's also plastic, which is bad conductor of heat. So that our LEDs are not overheated, I applied some aluminium foils and then added the LED strips on top of it. So in that way, when the LED strips get heated up, the heat is kind of distributed on a larger surface and radiated out more efficiently. Once all 4 strips were on the frame, I took it to the soldering station and connected them in parallel. By the way, I'm zooming past with a time lapse because I don't really know whether you guys would appreciate a full-blown soldering video. So let me know in the comments below if you would rather prefer a step-by-step detailed guide about it. Anyway, so next up I added a DC battle jack so I can power it from a 12-volt power source of any kind. Because we are soldering on top of aluminum foil, I took out my multimeter in continuity mode and checked for short circuits that might have happened, but luckily there wasn't any short circuit and all the connections in parallel were also properly made. So let's move on to the power testing. So with my fingers crossed, I connected the 12-volt power source to the LED strip, and to my surprise nothing blew up. And actually if you look closely on the power meter, uh, the power budget is exactly 20 watts, so that's pretty nice. Now with the power done and dusted, next I needed to build the diffuser. Eeny, meeny, miny, mo. I don't know what that is. But if it's some kind of a semi-transparent paper or plastic, then that's good enough for me. Turns out it's a vinyl frosting for glass with one adhesive side. So that's handy. So I roughly cut it down to size for the frame and trimmed off the excess. But it's still too transparent to be a diffuser, so I went back to dumpster dive and find something that fits a little bit better as a diffuser. This will do. I applied it on the adhesive side and trimmed off the excess, and with that done, the assembly for the prototype was made. Now it was time for us to move on to our 2 main lights. Now these main lights are practically no different than the prototype we just made, but they are quite a bit easier, as in the backplane is completely flat for one. Secondly, I don't have to apply aluminum foil as a heat spreader because it's already pre-applied, as it's a laptop monitor frame. The other thing is that we're going for a slightly higher power budget with 5 strips, so roughly around 25 watts. And yes, whatever we are doing 2 times because we have 2 lights. So I don't really know exactly how YouTube's retention works, how much attention span people have, but just in case this is too boring, please let me know in the comment. I genuinely mean it. I want to understand. So with that out of the way, I'm not gonna make you sit through an hour worth of soldering job. So here's the brief highlight of me soldering and adding the connections. It was a pretty smooth soldering work, but there was one hiccup. I short circuited one connection to the aluminum sheet below it. Nothing too big to fix. I caught the issue with the multimeter and resoldered the joint. Next up, I added the DC jacks exactly the same as before, and we are done with soldering. Next up, I trimmed off the excess plastic from the frame to prepare it for assembly. Next we have to build the diffusion layer, but before we do, I wanted to give the light a dry run and power on test, which went pretty smoothly without any surprises. Good. So next I went back to look for something that I can use for diffusion layer and found this lamination sheet. I don't know how well it will work, but let's give it a try. Yeah, it definitely needs some extra diffusion, but we'll figure that out later. For the time being, let's just cut it into shape and stick it to the frame. By the way, it may not seem very obvious at first, but if you notice carefully, I am making a lot of choices that are all fairly reversible. I can come back and make changes to it without needing to break apart stuff. This is intentional. I prefer to build stuff iteratively, in stages, and preferably sandboxed. Anyway, time for us to find something for the diffusion, and I think these butter papers would do just fine. Momita might not be very happy about it, but we'll figure that part out later. All we need to do is basically to cut them in shape and stick them up with cellophane tapes. I'm not even gonna use glue because I have commitment issues. Anyways, so once that is done, we are ready to assemble the frame, and once the frame is assembled, next step is to find a way to mount them. So for that, I found these kebab sticks in the kitchen, and I think I have an idea exactly just what to do with this. It's gonna be way more fun than something off the shelf. So next up, I modeled these frame holders in FreeCAD and loaded them up on Cura for slicing to 3D print them. So once the slicing was done, I put them on the 3D printer and it came out just nicely. Also, the time lapse came out pretty nicely, but it's rather long, so moving on. With all the parts at my hand, I started assembling the frame holder. Now, envisioning how it can come to be, designing it is very interesting, but actually manually assembling it is rather tedious. I'm not a fan of something that is repetitive in nature. In any case, it's not very complex design, it's just hold a frame upright. That's pretty much it. I did leave M3 screw holes at the bottom of it to keep it generic because I didn't know how would I mount it on. So let's just first go get the M3 screws from my stash and the M3 nuts as well, so that I can mount them on whichever surface I decide to mount them on. But that's not a decision we can leave up to future Deb anymore. We have to make that choice right now. So looking into my stash, I found out these clamps. I don't remember why I got them, but they seemed kind of promising. I should be able to mount them on tripod arms, but nope, it's too loose. But it wouldn't be called a breaker space if I didn't know the solution to this kind of exact kind of problems. So with a patent pending secret ancient technology, I fixed it right up, and then the clamps went on just fine. I screwed them down and then prepared them to mount the frame holder. By the way, I intend to change the design a little bit. I might actually make the frame holder 1/4 inch screw compatible so that I can just use normal tripod mounts and not have to jump through these hoops. That would be version 2. But for version 1, I think we are almost there. It's time to put everything together and see how it looks. It doesn't look half bad, does it? Perfection. Now, how do we power this up? First, we need some kind of AC to DC adapter. This old salvaged laptop power brick seems fine for that purpose. It is 65 watts, which is perfect for our two main lights. We also need some kind of a DC to DC converter to bring the 20 volt down to 12 volt ish. This one that we're using is a synchronous DC to DC buck converter capable of handling well over 10 amps of current, which is more than what we need. So once we set the voltage up with this potentiometer, let's power it up and let there be light. I know this is far from perfect or far from being done, but there's a certain element of beauty and adventure in this madness that I really enjoy.
As with being a small YouTube channel, we have the leverage to experiment a lot. Not a lot of people watching us right now. You are one of the first ones. A lot of these things that we're building right now will get replaced by newer, better versions that we'll be keeping on building. We can't wait to share that journey with you. And if you'd like to come along with us, please subscribe. We know that the audio sucks in this one, and we're working on it. So in the next video, you'll get to see how we fixed it. See you in that one.